everyone. In physics, law of conservation of linear momentum. Now we are going to see. In this law, there are two objects are there. The two objects are going along a linear path. Its first object final and initial velocity is equal to the second object's final and initial velocity. That is what we are going to see. Let us assume three stages. This is object 1 A, and this is object B. Its mass is m1. I put this mass is m1. These two objects are going along a linear path. The surface is linear. Both of the forces are equal. For example, this have 10 Newton means this is also have 10 Newton. Both are have same force, but the second object is started first and the first object is started lately compared to first object. Then what will happen means it will move forward slower than the first object. This is initial velocity u1 and I put is u2 because this is second object. So here only the velocity gets started. So this is initial velocity u1 and u2 I have to assume. Now I am increased the force for the first object. It will be attract to the object B. So it is called collision. In physics, the attraction between the two bodies is called collision. Let us assume like a diagram. This is object A as same m1, but it is attracted object B m2 because I am increased the force in the object A. Both are lying in the linear path. So this is called collision, right? This is called collision. Then afterwards this is called before collision. The collision before happens, so that it is called before collision. So these are the two assumes. Then it will be attracted to this object. Then the force is created here, Fa, like a force. The object A assume a force to the object B. Am I right? Yes. Object A assume a force towards the object B. So it puts a force upon the object B. According to Newton's third law, every action there is equivalent and the opposite reaction. Here the action was happens, then absolutely the opposite reaction also happens based upon the object B. So this is force B. So the force of object A applied to the object B. According to Newton's third law, every action that is equivalent and opposite reaction. Then the force of A gives means the opposite force also happens on base of B. B produces a force opposite to the A. So this is the second phase. And third phase, object A was stopped because it applied a force and it is neutralized, and object B move forward with the high energy because it produces energy to it. Then this is final velocity. Am I right? Yes. This is initial means the collision was happened and it is final velocity. Yes. Here the collision was happening. It is after collision. The collision was happened after what they are doing means that is assumed as after collision. So this is the diagram. Using this we have to prove the initial velocity of the two objects is equal to the final velocity of the two objects. Let us see in detail. According to Newton's third law, second law, according to Newton's second law, What is Newton's second law? We know well, F is equal to ma. Force is equal to mass into acceleration. Here mass is constant. Acceleration, on account of acceleration, we know the formula for acceleration, velocity by time. V is equal to A is equal to velocity by time. Change in velocity, that means final velocity minus initial velocity by time. Momentum means change in momentum also there, like that velocity is there means change in velocity also there. Final velocity minus initial velocity by time. Instead of velocity, we have applied the change in velocity. Now, instead of A, we have to substitute this in the formula. Yeah, F is equal to ma, we know well. Instead of A, we have to substitute V minus U by T. Then V into V minus U by T. M into V minus U by T. So, then what we are going to do? Here, substitute the force A. Here force is same thing. Substitute the force A and apply the initial and velocity we have to apply, and substitute force B and initial and final velocity we have to apply. Then what will come? Force A. The force applied to the object A is equal to M is constant. Here the force was acting towards the object B. Then we have to put the values of B. That means final velocity of object B minus initial velocity of object B by T. You have to oppositely doing this. Like that, force B is equal to M into, here FA gives the V2 minus U2 means, then FB gives V1 minus U1. I hope you are clear in this explanation. Force A acting towards the force B. So the force B application we have to write in this. And the force B acting towards force A. So we have to substitute the values of force A only. So final velocity of force A is V1 and U1. Initial velocity is U1 minus U1 by T. So here in Newton's third law, every action that is equivalent to opposite reaction. Then force A acting on force B, it is positive force, but the force A was acting towards force A, it is negative force. Am I right? Yes. It is positive force acting towards force B, but force B acting towards force A like negative force. So we have to assume FA is equal to minus FB, because force A acting positive charge, positive force, but FB acting on towards force A oppositely, so it is negative. Then FA is equal to FB. Now we know the value of FA. What is the value of FA? M into V2 minus U2 by T is equal to minus FB value. This is FB value. Here minus is came is, here we have to put minus M into, here it is plus. Now we are assuming the formula instead of this means we have to put minus M into V1 minus U1 by T. In this two case, the T is common. Yes, the T is common. We have to cancel it. T is common, we have to cancel it. Here, then what will comes? M into V2 minus U2 is equal to minus M into V1 minus U1, because the divided by T is cancelled, so we have to put this constantly. Then what will come? M into V2, MV2, M into minus U2 minus MU2 is equal to minus M into V1 minus M V1 minus M into minus U1 minus into minus plus M into U1 mu1. Okay, this is our last before process. The last process is we have to compare the both equations. So we have to get left side LHS, we have to get LHS final velocity, and we have to get a right hand side as initial velocity. Then assume mv2, this is final velocity mv2. Here the final velocity also there. Put that into LHS. Then minus mu1 given left side means plus, it will came to plus mv1 equal to here final velocity we have to assume initial velocity is there in the equation. Then minus u1 u2 is going to write RHS means it became positive mu2. Here we have to assume like that mu1. So this is the final answer of law of conservation of linear momentum. That means final velocity of two objects is equal to initial velocity of addition of two objects. So we have to prove this in this way. Hence proved. So you are confused in this process only. I will explain once again. So we have to, this is the equation that we are gotten. We are comparing the both equations. We have to came the final velocity in left hand side, initial velocity in right hand side. Then what will come? mv2 is there mv2. Then mv1 is there. Minus mv1 comes left hand side means it will become plus mv1 equal to here minus mu2 is there. It become right hand side means plus mu2 plus mu1. So this is a final answer of law of conservation of linear momentum. I hope you are clear. Thank you.